Hello viewers, in today's class we are going to solve yet another problem from greatest integer function, right? So here we have to evaluate a definite integral involving greatest integer function, right? So here we have to evaluate this integral from minus half to 3 and greatest integer square root of 1 over x plus 1, right? So let us start. So here let us first call this integral as I, right? So now here what we will do, will make use of the method of substitution, right? So let us first substitute t square is equal to 1 over x plus 1, right? So here's the method of substitution is a powerful tool in integration, right? So now here we take t square is equal to 1 over x plus 1. So therefore we can write x plus 1 is equal to 1 over t square, right? Okay, so now if we differentiate both sides with respect to x, we'll get dx over dt is equal to minus 2 over t cube, and dx can be written as minus 2 dt over t cube, right? So this is the expression for dx, right? So here we'll substitute this value for dx. Now the second step is to change the limits. Since we are changing the variable x to t, and here x varies from minus half to 3, right? So when x is equal to say minus half, then the value of t can be calculated from this expression. So now here we can write t square is equal to 1 over minus half plus 1, that is 1 over half, that is 2, and we can write t is equal to square root of 2, right? And when x is equal to 3, we can write t square is equal to 1 over 3 plus 1, that is 1 over 4, and t is equal to square root of 1 over 4, that is half, right? Okay, so here what we have done so far, we have substituted t square is equal to 1 over x plus 1. We have obtained dx is equal to minus 2 dt over t cube, and we have changed the limits, that is when x is equal to minus half, t is equal to square root of 2, and when x is equal to 3, t is equal to half. So when x varies from minus half to 3, t varies from square root of 2 to half, right? So now we can rewrite our integral I as we can write it as I, and here we have square root of 2 to half, because here t varies from root 2 to half, and we have greatest integer t, and for dx we can write minus 2 dt over t cube, right? So here this notation represents the greatest integer, and from this expression we have t is equal to square root of 1 over x plus 1, right? So now we can rewrite this integral as minus 2, and we have a square root of 2 to half, and we have greatest integer t dt over t cube, right? Now see, here we have a negative sign, so we can use the properties of definite integral, which says that we can interchange the limits by neutralizing this negative sign. So a to b, f of x dx is equal to negative of b to a f of x dx, right? So when we interchange the limits, we have a negative sign over here. So now we can neutralize this sign, and we have I is equal to 2, and we have half to square root of 2 greatest integer t dt over t cube, right? So now we have to evaluate this integral. Now viewers, let us concentrate on these limits. See, here we have the real number line, and here we can take 0, then 1, and then 2, right? And we see that this half, that is t is equal to half, it lies somewhere here, right? And the value of square root of 2 is approximately 1.414, and square root of 2, it lies somewhere here, right? So this is square root of 2, right? And we see that between half and square root of 2 we have the integer 1, right? So what we will do, we'll break this integral as a sum of two integrals, right? So now we'll write it as 2 times of I1 plus I2, and I1 is from half to 1, that is we can write 2, and here we can write half to 1 and greatest integer t dt over t cube, right? And I2 is from 1 to square root of 2, right? So I2 is from 1 to square root of 2 greatest integer t dt over t cube, right? So now this is the situation. See here, half and square root of 2, it lies between this positive integer 1. So we'll break this integral as a sum of two integrals, right? So the breaking point is 1, and the first integral varies from half to 1, and the second one it varies from 1 to square root of 2, right? So now we have to solve these two integrals, but before solving these two integrals we have to make use of the definition of greatest integer function. Now viewers, as per the definition of greatest integer function, see here t varies from half to 1. So when t is or it lies between half and 1, then the value of greatest integer t is equal to 0, right? Because this is the definition of greatest integer t, and when t lies between half and square root of 2, then we can write the value of greatest integer t as equal to 1, right? So when t varies from half to 1, then the value of greatest integer t is 0. For example, if we take a value, say 0.6, it lies between half and 1. So the value of greatest integer 0.6 is the greatest integer less than or equal to 0.6, and that is obviously 0, right? And here if we take a value, say 1.2, then the greatest integer 1.2 is the greatest integer less than or equal to 1.2, and that is 1, right? So this is how we have these two values. So now we'll make use of these two values. So here when t varies from half to 1, the value of this greatest integer t is 0, and when t varies from 1 to square root of 2, then the value of greatest integer t is 1, right? So when greatest integer t is equal to 0, so this integral is 0, and we are left with only this integral, right? So now viewers, the value of this integral is 0, so we are left with 0 plus, here we have 1 to square root of 2, and the value of greatest integer t is 1, and we have dt over t cube, right? And we can rewrite it as 2 times integral from 1 to square root of 2 and 1 over t cube dt, right? So now this is a very fundamental or basic integral, and here we'll make use of the result, that is x raised to n dx is equal to x raised to n plus 1 over n plus 1, provided n is not equal to minus 1. So here we have 2 times integral 1 to square root of 2 t raised to minus 3 dt, and we have t raised to minus 3 plus 1, and as per this rule we have minus 3 plus 1 and 1 to square root of 2. So now if we simplify it, we have 2 and 1 over minus 2 times t square, right? And the limits are from 1 to square root of 2. Now this 2 and this 2 get cancelled, and we can take minus sign outside, and we have 1 over t square, and the limits are from 1 to square root of 2, right? Now we can simply substitute the limits, and we'll take the difference. So we have 1 over root 2 square minus 1 over 1 square, and I is now equal to minus, this is 1 over 2, and this is 1, because root 2 square is 2 and 1 square is 1, and we have minus half, and that is plus half, right? So viewers, the value of this integral is equal to plus half, that is plus 0.5, right? So this is how we solve this important problem related to greatest integer function.